Flack math! Give me some math and I'll give you some flack. Flack math!
So we're going to analyze, in lesson 22, we're going to analyze continuous, discontinuous, and discrete functions.
I cannot write all that down. I'll just remember it. Maybe.
Yeah,
For sure.
you'll forget.
Yeah, I know.
Okay, so a relation pairs input values x from the domain with output values y from the range. A function is a specific type of relation where every value in the domain must be matched to only one value in the range. So we talked about this, yes. Okay. All right, they'll call me from the radio, so saying that she's here, but because technically that's how we have to communicate with parents and stuff. But if we don't hear it in the next 30 seconds, then you can just go down. All right, so a continuous function. So you might want to write this down. Continuous function.
I don't like writing though.
Continuous function is a function with a graph that has no gaps. Kind of makes sense, right? No gaps, no jumps. Or, here's a fun word, asymptotes. Okay? So I'll show you what that is in a second. Okay, so no gaps. No jumps. No asymptotes. The P is silent. It's still very awkward to say. Any function that has gaps, jumps, or asymptotes is considered a discontinuous function. It discontinues, it stops, or it jumps, or there's a gap, all right? Discontinuous is gaps, jumps, or asymptotes. Sounds like some type of rash or something.
Well, no, it wouldn't be because
Whoa.
it comes from asymptomatic, right?
Sure.
All right. Like the same root as that.
It does. We've seen that word a lot, haven't we? Lately. Symptomatic. Okay. All right. So, a discrete function is a type of function made up of separate, disconnected points. Okay. So a discrete function, and these will be a lot easier when I show you and not just tell you.
Okay.
Separate, disconnected points. All right, so here's some examples of continuous functions. Just a regular linear equation is a continuous function. A parabola that looks like that, that's a continuous function. See how there's no gaps in the line? There's no weird jumps. There's no dotted line looking thing. That's an asymptote. I'm going to show you that. But here's some examples of discontinuous. So if it looks familiar, if it looks comfortable, it's probably continuous. But discontinuous might look like this. See how these are two separate weird looking graphs, okay? There's a gap here. There's space in between. There's also what we call an asymptote. So this asymptote might look like this. So an asymptote is a border that something approaches without ever touching it, okay? So think about the function dividing by 2, y equals x divided by 2. Or just divide something by 2. Divide 1 by 2, you get 1/2. All right, divide 1/2 by 2, what do you get? Cut it in half, you get 1/4. So see how it keeps getting smaller and smaller and smaller, but never gets to 0. You got 1/32, cut that in half. 1/64, cut that in half. 1/128, 1/256, 1/512. See how it keeps getting smaller and smaller, but never approaches 0. That's called an asymptote. All right? Here is another kind of discontinuous function. If you have something that looks like this, steps. See how there's jumps there. There's jumps and gaps, but there's jumps. This is like another example of a discontinuous function. All right? And basically what distinguishes a discontinuous with a discrete function is that discrete functions are actual points, just single locations. Okay, those are like discrete functions. Or it could be like a line, it forms a line, but it's like all the integers or something like that. So if the domain is like just the integers, then that would be more of a discrete function. Okay, just individual points. So I haven't heard anything, so I'm assuming you can
I saw
go.
the office lady walking up and down the hall. I think she was looking for
Okay, so yeah, do you want to just head down there?
Is that like okay?
Yeah, yeah. I mean, they'll send you back up if it's not. So better to be safe than sorry. Okay, so can you guys identify the differences on a test? If they gave you this function, would you be able to say this is a discontinuous function? Okay, because there's a gap. It's not connected. It's not continuous. It's not connected. This is not connected. There's a jump there from each line. There's multiple things on the graph. When there's multiple things on the graph, then it's either discrete or discontinuous. If there's only one thing that's connected, that's continuous. Okay? And if it's discrete, it's just points. It's not lines, it's just points. All right. So this is pretty easy stuff. The examples, the homework that you're going to get is going to be like, hey, graph this discrete function. And so it's just going to give you like 3 points to graph. That's it.
Okay.
There's not a lot of rhyme or reason to some of this, but some of it actually makes sense if they give you an actual domain or things like that. But here's what example 1 looks like. Graph this discrete function, or graph the function and state the domain and range. So graph and state D and R, okay? So here's what example 1A looks like. So F equals 2, 3, 4, 5, 6, 7, and -1, 0. So this is kind of pre-algebra stuff, but I guess the domain and range, identifying that, you did this on your last test. Remember, the domain is just the x values and the range is the y values. So 2, 3, 2, 3, 4, 5, 6, 7, -1, 0. Okay, now the temptation is to just connect those dots.
Oh, would it be so
so satisfying.
I know, it would be satisfying, but it's not. That's not the function. So you're not picking these points to see what works in a linear equation. If you're doing that, then that's a continuous function. You have to include those points and everything in between. But this is the function, just 4 points. So what kind of function is this?
Discrete.
It's discrete. And the domain is just the x values, 2, 4, 6, and -1. I would probably put the -1 first. And then the range is 3, 5, 7, and 0. Right? That's it. That's how you answer that question. All right, let's graph this function. I want to graph g of x equals x plus 2. How do you graph this function?
It smells like grilled cheese.
It smells like grilled cheese.
It really does. So nice.
I can't focus.
Oh, I'm so hungry.
Oh my gosh, that is not a line.
Yeah, it kind of goes there.
Are you drawing a line
I'm trying to on the graph because it won't go
on
straight.
this? Oh. Yeah, don't connect
No,
those.
not
dots.
that. I'm
Okay.
talking about like this.
All right. So what about this function? G of x equals x plus 2, or in other words, y equals x plus 2. You guys know how to graph that, don't you? How do you graph it?
Where are we on?
B.
Here we go.
Just put a dot x2.
Oh, dot it.
Okay, and then what?
That's it.
That would be g of x equals 2.
Yeah.
But this is g of x equals x plus 2. This is a linear equation.
Yeah.
Okay? So we follow the slope. What's the slope? Can you guys identify the slope? 1 over 1, right? Rise over run. So it's up 1 over 1, up 1 over 1. So this is what the graph looks like. Now this time we have to connect the dots because it's everything in between. It's not just 0 and 2, it's like 0.1 and 1.9 and 0.2 and 1.8 and everything in between, right? Okay, so what's the domain and range? What's the domain? What are the x values of this line?
0.
Yeah, 0, 1, 2, 3, 4, 5.
Well.
Oh.
All the numbers.
All the numbers.
All
x's.
the
See
numbers.
how these arrows point in, they go on forever. So the x values will go to a negative infinity all the way to positive infinity.
But
Okay?
that's hard to think about.
All real numbers. So all real numbers. And then what about the range? What are the y values of this? All real numbers. Okay? So all linear equations will have, most of the time, will have a domain, all real numbers, and a range, all real numbers. What are the only types of linear equations that don't have all real numbers? Can you guys think of a linear equation that doesn't have that?
Yeah, just a line.
Yeah, well, like
Well,
a
yeah,
horizontal
yeah,
line.
Horizontal.
Horizontal line has, the domain is infinity, right?
Horizontal.
Right, Gracie? Right? It's infinity, but the range, it's just like one number the whole time because it's a horizontal line.
And
There's only one y value. But when you think about a vertical line, well, that domain, what are the x values of a vertical line? Just one number, right? It doesn't change. But the y values go from negative infinity to positive infinity, okay? So that one's a little tougher to get your head around. Anytime you're dealing with infinity, it's a little tougher to get your head around. Okay, now discontinuous functions have specific places where they are not continuous. A point A above. Let me show you this. This is another example of a discontinuous function. Now, right now, this is continuous, right? But as soon as you put an open circle here, that means that point, remember what an open circle means? It means do not include that. So when you're graphing x is less than 2, you circle the 2 and then shade to the left, right? So this is what this means. That is a gap. That is a gap in the system. Okay? So that is called a point of discontinuity. Point of discontinuity. You guys know what continuity is in film?
No idea.
Oh, continuity. I remember this, but
Continuity?
Oh, you want me to explain?
Yeah, do you have like an example in film of continuity issues?
the films just don't add up. Like the person's doing one thing in one shot, and then
Yeah. Yeah, like they're talking with their hand, like they're
let's just say they're like talking with their right hand, and then the next shot they're talking with their left hand because it cut through scene.
Greatest Showman when Hugh Jackman hugs his wife at the end. His head is on the left shoulder, and then the next shot, it's on the right shoulder. Pretty, sometimes those continuity issues are unavoidable. Like it's the only thing that works, but
Never gonna watch The Greatest Showman again.
it's a lot
It's like
cheaper to just live with the continuity mistake instead of
Why don't they just
hiring,
refilm it?
because it's
because that's
expensive.
millions of dollars to get Hugh Jackman
Yeah.
back in the.
Yeah, just you.
I need you to hug this lady. I'll give you $1 million to do it.
Dude,
Um,
I'm getting $100 for him.
So, discontinuity, this is where it's not consistent. This is where it changes. There was a nice pattern here, and then that thing ruined it, okay?
One thing.
So that's a point of discontinuity. All right? The second graph, let me show you another graph.
Now it smells like bone kind of.
Okay? You guys have probably seen a graph like this before, but this is discontinuous because there's two of them. So the second graph above is discontinuous at the line x equals 0 and y equals 0, but it's discontinuous here.
So if they were both touching
The 0.
0, it would be continuous even though they're not part of the same line.
No, they wouldn't be, because then you'd have, yeah, it's just whenever there's two graphs on there, it's not going to be continuous. It's discontinuous.
The asymptote.
And it wouldn't be a function if they were both touching the same line.
Asymptotes.
Then
The asymptote.
then you'd have multiple y's for the same x.
So the
So
little,
it doesn't necessarily have an asymptote.
the little
doesn't
dotted
have
line is
to.
asymptote.
Yep.
Got it.
So it doesn't really have a point of discontinuity, but it is discontinuous at the line x equals 0. Okay? All right. So I'm going to show you a couple more things identifying some types of functions. Okay, and then this will be it. But identifying domain and range, remember domain is the x values. So when it's listed like this, identifying the domain and range is pretty easy. I think all of you got that right on your test. Okay? But when it's on a graph, The domain is basically all the x values are basically how wide it is. And the range is how tall it is, all the y values, because x measures left to right and y measures up and down, right? So let's identify some types of functions. So this is example 2. Here's 2a. All right, this is a parabola and it represents a quadratic equation, but this is a continuous function. And it's a function because if you do the vertical line test, there's only one y value for every x value.
Now it smells more like popcorn.
But if that parabola was sideways,
Definitely popcorn.
then you'd have multiple y's for one x. So that would be continuous, but it's not a function.
Right.
Okay, and
They need to share.
so B would be, well, let's look at another example here.
I can't write today.
I definitely smell the pancakes though.
Oh, I smell food. I'm so hungry.
I'll go ahead and solve it.
Okay, identify if this is continuous or discontinuous. Ready, go.
Wait, what was the question?
Continuous or discontinuous?
Discontinuous.
Okay, and what is the point of discontinuity? Gmo.
It's the circle.
Yes, which is
5, 2.
Oh, 4.
looks
It
like
is 4, 2. I'm sorry.
4, 2. So 4, 2 is the point of discontinuity. Good. Is of disc. Let's just write that. Okay, what about this? What kind of function is this? What is that?
The other one.
Discrete. And so there's not really, it doesn't make sense to identify the points of discontinuity,
Because it's all
or
over.
the points of discretion, or discretion. Is that the same word? Discrete.
Yes.
I don't think discrete and discretion can go together. I don't know.
So we just say discrete.
Is discretion? No.
Pretty sure.
I don't think so.
And you can say function because as far as you know, there's not multiple y's for the same x. There's only 4 points and it doesn't look like the vertical line test will do anything weird. Okay?
We're gonna say
We are. Did we get in trouble? Would we get in trouble?
Okay, now the other part of this is identifying the domain and range. Okay? So you have to define whether it's a continuous, discontinuous, or discrete, but then you have to identify the domain and range. Okay? Okay, so what is the domain and what is the range? Let's start with the domain. Remember, the domain is how chubby it is, right? How chubby is this function?
all of the numbers except those
Very,
2 points.
very chubby, right? It goes left and right, but there's a couple points of discontinuity. Okay?
It's like 2 and 5.
So the range, it's probably easier to say what the domain is not. It's only 2 numbers, right? What is the domain not?
2, 3, and 5, 3.
Or,
We'll just add 2 and 3. 2 and 5.
Oh, right.
okay, good. All right, what about the range?
It would just be.
It would.
See the same.
Okay, so the range would be.
It would be all real numbers, right?
No.
Wait, not all
because
real
it
numbers.
doesn't go up.
Yeah. Sorry. Everything. Wait.
it'd be numbers greater than
So you would say the
So
real
numbers
numbers.
less than 3.
Okay,
less than.
less than 3?
Yeah, all of them less than.
But what about this
Greater
line
than
in
or less than
between?
3? Wait, no, equal to or less than 3.
Yeah, so y is less than or equal to 3. Okay?
We got there.
Even though this
I just tried every other option.
even though this 3 is not
Yeah.
located, but these 3's are.
Yes.
So 3 is still part of the range. Girls, are you paying attention? Because this is important, and you're gonna miss it if you're not paying attention. So, see, this line says 3 is in the range, but this says it's not, but you gotta go with overall, 3 is in the range. That's one of your points.
I just thought.
Okay, so this would be discontinuous, and then you have to identify the domain and range.
Didn't expect that.
Okay, tell me what kind of graph this is, and identify the domain and range. What kind of function is that?
Continuous.
Continuous, and what's the domain and range?
The range is greater than or equal to 0. and the
Okay, so
domain
y
all
is
real
greater than or
numbers.
equal to 0, good. Because it's on that 0. This is the bottom of it and the top of it. You're looking for how far down it goes and how far up it goes. Okay, what about the domain?
All real numbers.
All real numbers, good. And it's, what kind of, yeah, continuous, we got it. All right, one more. Feels like we're doing the same problems over again.
This math class was a lot easier than Tuesdays. I
Discontinuous.
was so confused about those functions.
And domain and range don't matter. Or
It's discrete.
yeah, discrete. That's not what I said.
You said discontinuous.
Okay, so what's the domain? And what's the range?
Okay, so cares.
Domain is.
Domain would be
It's discrete. Oh, you can't abbreviate discontinuous DICS.
You can do DISC.
Well, DI, discrete.
No, you can't.
DISCS.
You just say disco.
Disco.
Yes, yes.
Disco and discrete.
Disco and disc.
Disc. No.
Disco and disc.
Okay, what's the domain? What's the farthest? So you can't really do a range because it's not all real numbers, but they are specific 4 points. So what are the x values? It's like 2.
5, 6, 7.
5?
You can't really see because like
Is it 2, 4,
2.
6, 8?
Yeah, let's just go with that.
I think it looks to me like
What about the range?
5, 8, something like another 4.
Y equals 4. That's it. Okay. So when you're listing the domain and range, sometimes you can say D equals all real numbers. But if I say R equals Y is greater than or equal to 0, or Y, or R equals Y equals 4, no. It's use a colon or something. Y R is R colon Y equals 3. D colon X equals 2, 4, and 6.
Okay. Y, yeah, R equals Y equals 4. You can't have 2 equals.
Yeah, it just looks weird. So, you guys good with this?
Yeah.
For some reason, if you're not a visual person, this is confusing because sometimes it's hard to see. Well, how far left does it go and how far right does it go? How far down does it go? How far up does it go?